Hi guys, okay, back here today to look at question 9 and 10 from the 2018 paper, the final two questions of this paper. So let's get straight into it. These two questions are from section B, and in section B, these questions are a little bit longer. The triangle PQR is shown in the diagram, where P is 3, 4, Q is 11, 4, and R is 3, 10. Okay, we can see it here. Draw the triangle ABC on the same diagram where A is 1.52. So let's put that in first. So 1.52. So the 1.5, that bit means the x-axis, okay? So let's get 1.5 on the x-axis. It's here, roughly, and 2 on the y-axis. So that bit there is for the y-axis there. So they meet roughly here, okay? B is 5.52. So 5.5 is here, 2. So about there. And C is already marked actually. So let's draw that triangle. Get your ruler. Okay. And then join these two. Okay, now don't forget to label the points. C is already labeled. This is A, this is B. Okay. The triangle PQR is the image of the triangle ABC by an enlargement of scale factor K using 0, 0 as the center of the enlargement. Use the lengths of PR and AC to find K, the scale factor of the enlargement. So let's get the length, first of all, of PR. So what is the length of PR? Because that's what they're looking for first here. Look, they're just asking for PR first. Okay, so we'll find the length of that first by just going back up to the diagram. PR is from here to here. So what's this length? Okay, well, it looks like it goes from 4 if we count the boxes actually. So 1, 2, 3, 4, 5, 6. So that's 6 units. Now they want us to get AC, the length of AC. So let's look at that one. So AC, we have 1, 2, 3. Okay, 3 units. Now, that means that the scale factor K, the scale factor is 2 because PR is twice as big as AC. Okay, so PR is twice as big as AC. In other words, we'd have to multiply the 3 by 2 to get the 6. Okay, it's twice as big. So that means if it's twice as big, the scale factor is 2. The triangle the triangle PQR has a right angle at P. Use Pythagoras theorems to find the length of QR. So we have to get the length of QR. Okay, so we're well familiar with Pythagoras theorem at this point. We should be. So we have to get the length of this. So when you're doing this question, remember that this is the hypotenuse, and we call that C, the letter C, and this is the letter A, and this is the letter B. So because Pythagoras theorem is C squared equals to A squared plus B squared. Now, A, we know already, we counted the boxes there, that's 6, okay? B, this down here, let's count the boxes, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 units long. So we have two sides, we have the A and the B bit, we just have to figure out the C bit. So let's go down here and do it in the box down here. So C squared is equals to A squared plus B squared. C squared is equals to A, what did we say A was? 6, and B is 8. Okay, squaring these. 6 squared is 36, 8 squared is 8 eighths, 64. Add them together, we get 100. So c squared is equal to 100. C is equal to the square root of 100, which is 10. Okay. Use your answers, so part 4, use your answers to part A, part 2 and 3 to find the length of BC. So they're asking us now to find the length here of BC. Well, we already know that that side A was 6, and we knew that this side here was 3, which is half. Side B here is 8, so this would be 4 down here. AB would be 4. 1, 2, 3, 4. So in other words, what I'm saying is because we have a scale factor of 2, that means that all the sides in the big triangle are twice as big as the one in the small triangle. Or another way of saying it is the sides in the smaller triangle are half that of the sides in the big triangle. Now we now know that this side here, we now know that to be 10. So if that's 10, then this must be 5. Okay. So the answer is 5. So 10 divided by 2, which is 5. The area of the triangle ABC is 6 square units. Using this or otherwise, find the area of the triangle. Well, I think the easiest way to find the area of the triangle is just the half multiplied by the base by the height. So the big triangle here, the height is 6, the base is 8. So area is equals to a half base multiplied by height, which is equals to a half. The base was 8, the height was 6. When you multiply out that, you get 24. Okay, units squared. Okay, it's tricky enough question that was. Now let's have a look at this next part B. Frankie had to do the following calculation. To begin, he makes an estimate of what the answer should be. By writing each number correct to the nearest whole number, use the boxes below to find it. So we have to write each number like to the nearest whole number. So that to the nearest 251.3. So that's 251. Okay, to the nearest whole number. They've done the 39 one first. 10.3 to the nearest whole number. So it's between 10 and 9, but it's closer to 10. Okay, let's add up the top line there. We'll get 290. And the bottom line is 10. Okay, and then divide. 290 divided by 10 gives us 29. Now, next he uses his calculator and gets the 255 over 12.12 for his answer. Because of his estimate, he knows this answer is not correct. Frankie gets his incorrect answer by keying the following into the calculator. So what does he do? He adds the top line and then divides by 10.3. We'll explain why this does not give the correct answer. Okay. So he added the top line. Yeah, I think he needed to put in brackets here, because what the calculator would do in this case is here, it would do this division bit first. Okay, because you do division because of BOMDAS or BEMDAS. So BEMDAS, that means the calculator knows about this. And if there's any division or multiplication, it will do that before any adding or subtracting. Okay, so let me just check on my calculator. Is that what happened? Let's see what happens if you put in a bracket to do the addition. Like really, he should have put a bracket around this and this. Okay, so if you get your calculator now and try that. So bracket 251.32 plus 39.14 divided by 10.3. And we get 28.2. Okay, so that was the problem here. Explain. So why doesn't this? He forgot. So he forgot to put brackets around the addition part. Okay. Use your calculator. So I've already done this. To use it was 28.2, which is pretty close to our estimate answer of 29 in the first part. Okay, that is question 9, guys. I'm going to get a video now for question 10.